working? Hello, my name is Mohsen Janmaleki. I am here to introduce our innovation in measuring end-tidal CO2. Actually, we call it CapCNT and is a capnometer. So what's the problem? The main problem in emergency medical services is to understand how the tube is inserted. Is it in the correct place or not? Uh, so if you have a device to detect that intuition is correct, so we can prevent a lot of severe complication and even deaths of the patient. So there's measuring CO2 is known as the gold standard for understanding whether the tube is in the correct place or not. But there is about that most capnometer or capnograph are bulky, expensive, and relatively slow in response and need to be calibrated. So what we have introduced is a sensor, a very fast sensor that is mainly developed using multi-wall carbon nanotubes grown on the silicon wafer. That pattern is in a way that to measure the electrical resistance that changed because of a conductive polymer that is sensitive to CO2. So the sensor is attached in a plastic extension that can be used for normal intubation or standard intubation tubes. And a detachable electronic board can be attached to the sensor and show the end-tidal carbon dioxide changes as well as the respiratory rate. So there's a report that about 15 million intubation occurs in United States, and it's estimated to about 50 million in the world. So if we can provide the sensor for just 1% of this huge market, it means that we can provide about 500,000 sensor. And if we can earn just $5 for each sensor, so it means that we can make $2.5 million from this market. The electronic board is we estimated to be around $80 to $100 when compared to available capnometers that are cost about $2,000, so it's relatively non-expensive. And the sensor that is detachable and disposable, it costs about $20. So when comparing again to the cost, so it's very economical.
Thank you. What is your prescribed market? Is this going to be for just in-hospital use, or do you see it for out-of-hospital use, such as an EMS?
Actually, it's designed for EMS because the patient in that situation are are in emotions, so it's very hard to understand is the tube in the correct place or not. But also, it can be used in ICU and operating rooms.
Product to market, what type of testing is required, commercialization, product, medical device testing, and where are you in that process?
Fortunately, this sensor is not invasive, so it's not categorized to the invasive devices. And because the gas sensing, the CO2 or other gases that they measure in the medical services are well developed, so it is not a big deal to use that categories in the FDA, for example.
So you've got an interesting story to tell here. You mentioned EMS might be relevant. What's your plan to take this story to the market to truly validate what you're proposing, and how can you generate a real ROI in the eye of the potential purchaser?
That sensor actually is attached to the standard intubation tubes. And we have tested in the labs. It works. We change different gases and different concentration, and it works. But we haven't yet tested on animals and humans. So the next our plan is to check in animals. And I think it would take at most 2 years to have the product in your hand.
Okay, thank you very much.